Hello Year 10, this is Mr. Radmall welcoming you to Particles and Radiation 2 topic, Lesson 6. And we are going to be talking about getting energy from the atom, nuclear power. So your driving question, how is a nuclear power station different to a nuclear bomb? And starter question is, how much electricity do you think is generated in the UK by nuclear power? So what percentage of electricity that comes through our sockets, that powers our microwaves, hair straighteners, games consoles, how much of that is coming from nuclear power? Pause the video. Okay, it is in fact 21%, so about a fifth of all electrical energy generated in the UK, nuclear power. So here's all the other ways of making electrical energy. And nuclear is really important because for many reasons, but one important reason is that nuclear power does not produce carbon dioxide, whereas gas, oil, and coal do. Another important point about nuclear power is that the fuel used, we have lots of it. It won't run out anytime soon. So nuclear power, very controversial subject, important to know about. So here's a nuclear power station. So what's going on inside that nuclear power station? Well, it's got a lot to do with this metal. It's called uranium. Uranium is the fuel used by nuclear power stations. Okay, and let's talk about how it's used. So here's a nucleus of uranium. If a nucleus of uranium-235 absorbs a neutron, it will become unstable and split into smaller nuclei. And also, making smaller nuclei, and also a few more neutrons are given off, and also, here's the important bit, a little bit of energy is given off as well. So this is called a fission reaction, and it involves a uranium nucleus splitting into and making energy. So here's another diagram to show this. It's uranium-235 isotope, and as you can see, it all kicks off with a neutron. Well, once uranium nucleus splits into two, there's some more neutrons. What are those neutrons going to go and do? That's right, they're going to go and find more uranium nuclei and split them up, which will make more neutrons, which will then go on and so on. Looks a bit like this. So in uranium, when fission's happening, the trigger is the neutron, and every time a fission happens, more neutrons are produced. There it is there, look, and it goes on and on and on and gets bigger and bigger and bigger and bigger. This is called a chain reaction. Okay, so that's a lot of info. Let's think about this reaction, a fission reaction, where a nucleus splits into two and makes energy. So have a read through these stages, and then just don't copy the stages out, just put the numbers in the right order. What's the correct order of these stages for fission? Pause the video. Okay, let's go through it. So first up, a nucleus absorbs a neutron. Then it splits into two smaller nuclei, sometimes called daughter nuclei. Also, neutrons are released. More neutrons are released than absorbed. The released neutrons are absorbed by other nuclei. These multiple nuclei split, each releasing neutrons. And of course, every time there's a split, there's some energy being given off. So in what's called a nuclear reactor, inside the nuclear power station, that's where the uranium goes, the fuel. Okay, So that's where the fission's happening. That's where the uranium nuclei is splitting up and making energy. Now, another important part to know about a nuclear reactor is how to control the reaction, how to make sure that it's controlled and safe and can be stopped. And that's where the control rods come in. So control rods move into and out of a nuclear reactor, and their job is to absorb neutrons. If you absorb the neutrons, you stop the reaction. So they actually move in and out. So when we want lots of fission, lots of energy, lots of electricity, we move them out. When we want to slow it down or stop the reaction completely, we put the control rods back in. Okay. So, and then what happens in the nuclear reactor? Well, it gets hot. So nuclear power is just about using fission, uranium fuel, to get hot, turn water into steam, steam turns a turbine, turbine spins a generator, electrical energy is made, just like actually a coal, oil, or gas powered station. So another just important point to make about in a nuclear reactor, for a uranium-235 nucleus to split in two, the neutron has to be going slowly, which is kind of the opposite of the way you think. You'd think it'd have to have more energy and be going very fast. No, it needs to be going quite slowly. Okay, so the neutrons that are released during fission, they're going too fast. So there's actually also what's called a graphite core to slow the neutrons down. Okay. So the third part of a nuclear reactor, graphite core to slow the neutrons down so they're traveling at the right speed to cause fission. Right, well, that's a controlled fission reaction. That's when we're in charge and we're controlling it and making sure it doesn't get out of control. What about an uncontrolled nuclear reaction? Well, I'm talking about the bomb. I'm talking about the nuclear bomb. Let's just quickly go through some points here. So nuclear bombs are used, which you've probably learnt about in history, I would have thought, in terms of the bombs dropped in Japan during the Second World War. They use uncontrolled chain reactions. So there are no control rods involved. So for the chain reaction to happen, there has to be a certain amount of uranium atoms. This is called a critical mass. Okay, and then a nuclear weapon works by putting enough uranium together so it starts an uncontrolled chain reaction of fission. This results in uncontrolled chain reactions, and it makes a huge amount of energy very quickly. Unbelievably destructive. So this 4-ton uranium bomb was similar to the one used during the Second World War in Hiroshima, Japan, and it's got the same power as 20,000 tons of high explosives. Okay, so let's round up some of these ideas. Which of these statements is a porcupine, which is East London slang for lie? Pause the video and pick, please. Okay, so it was in fact D. Control rods move in and out of a reactor to absorb neutrons and control the reaction. So, to sum up, fission involves a uranium nucleus absorbing a neutron and becoming unstable. An unstable uranium nucleus splits into daughter nuclei and more neutrons. Neutrons created in fission cause a chain reaction, which involves a rapid increase in energy. And the control rods move in and out of the reactor to absorb the neutrons and control the reaction. Okay, so now for orange, number 1, can you draw a simple diagram showing a uranium nucleus during fission? What happens? I'm just talking, it doesn't have to be too much detail, just circles and labels. Okay, so you need the neutron, uranium nucleus, etc. Okay, see if you can draw a diagram of that. Then, what is fission? Can you define what fission is, or what a fission reaction is? Describe what's happening during a fission reaction. And then for yellow, can you define a chain reaction and explain how the control rods control the reaction? So what's a chain reaction? What are the control rods doing to control the reaction in a nuclear power station? And then for combine, can you compare how fission works in a nuclear power station and how it works in a nuclear weapon? Keywords in the yellow box. Pause the video. Okay, let's go through this. So to show fission in diagram form, just draw a circle. You can just draw a circle for the nucleus. You don't need to show all the protons and neutrons. You've got a neutron absorbed by uranium nucleus, splits into smaller nuclei and more neutrons. Right, next up, what is fission? During a fission reaction, a uranium nucleus absorbs a neutron. It then splits into smaller nuclei and more neutrons. This also releases energy, which can be used to generate electrical energy because the reactor gets hot, heats up water, makes electrical energy. So chain reaction is when more neutrons are emitted from a fission reaction than absorbed. The neutrons go on to create more fission reactions. The number of the fission reactions increases quickly, which means a large amount of energy is created in a short amount of time. Control rods that absorb neutrons move in and out of a reactor, and this can increase or decrease the chain reaction or stop it completely. Okay, and a nuclear weapon. The fission reactions in a nuclear power station are controlled by control rods that absorb neutrons. In a nuclear bomb, there are no control rods, so each neutron creates a fission reaction that can then go on to create another fission reaction. So the chain reaction allows it to simply run its course. Now, this means a huge amount of energy is created in a very short amount of time. An explosion. Okay, so now can you copy and complete the plenary statement, please? Where are you today with nuclear power and fission? And as ever, year 10, don't forget there's a show my homework quiz for you now to complete, and all results will be recorded. Stay safe, year 10. I look forward to seeing you at lesson 7.